I have the pleasure to introduce Nikolay. He'll be speaking about the delay accounting, an underrated feature of Linux kernel. So a round of applause for Nikolay.
So today we're going to talk about delay accounting, but in fact, when I finished my talk, I realized that it's talk about CPU and CPU usage in general. So let's start. A few words about me. I'm an ops guy. I worked as a classical system administrator for a while. My last employer was like pretty big internet company, and I served as the head of infra there. And since then, I try to make observability easier for developers. And currently, I'm CEO and co-founder at Karoot. We built an open source observability platform based on the BPF. So take a look on GitHub. So let's start talking about CPU. Modern systems such as Linux, they are multitask systems. They can run many processes on the same CPU core. And in fact, roughly speaking, each CPU core can handle only one task at once. And we have a scheduler that distribute the CPU time across all our processes. And the default Linux scheduler is CFS, which stands for Completely Fair Scheduler. And it takes several factors into account to distribute CPU time. It can distribute CPU time based on the CPU usage of the particular processes, their cgroup configurations such as quotas or priorities, and also the operation system level. You can adjust process priorities. And the conclusion of that is that CPU time is not always spread equally. So some processes can get less CPU time than others. And I think of it from the developer's perspective, or even from application perspective. We run our applications and they require CPU. CPU time is some sort of resource, and our applications are consumers. So, it's a bit weird to hear how engineers talk about CPU from the node perspective. We have like CPU usage on the node 60%. Is it better? Is it good? We don't know. And in our case, we just have some set of processes on our node and a set of CPU cores which can execute our tasks. And from the application perspective, there is only one issue with CPU-related issue. Not enough CPU time. For example, if the application required more CPU time than it has, it increases its latency. And we should consider any lack of CPU time as an added latency to our application performance. And I want to talk about it and how to measure it to make it clear for developers whether we face some CPU-related issues or not. And before we talk about right metrics, let's discuss existing metrics that we know about. Every monitoring solution offer us some CPU-related metrics, and let's take a look at them. The first one is load average. It's like most popular interview question when you hire some old school system administrator. Nobody knows the meaning, and but it's literally the number of tasks in the scheduler queue. So it's some few numbers that represent averages over a specific period, such as 1, 5, or 15 minutes. But literally, load average 16 here means that on average 16 processes were waiting for a CPU time in the scheduler queue. And this metric doesn't take into account the number of CPU core, and we can see a lot of stories on the internet about, how to make some decision based on load average, but every time it's pretty funny explanations about it, like under 50 it's okay, over 50 it's not okay, and so on. Now let's look at CPU usage. CPU usage, node level CPU usage, literally the percentage of time CPU, like single CPU core or all CPUs in general, were running some tasks. It signifies saturation. And in general, we cannot say 100% CPU usage, it's good or not, and is it problem or not? The answer, the only correct answer is it depends. And since nowadays we operate containers and many observability tools and monitoring solutions offer us container CPU usage. Container CPU usage is the amount of time each container consumes CPU time. For example, if during the some period, for example, 1 second, our container consumed 200 milliseconds, it can be interpreted as 20% of single CPU core. And this metric also doesn't answer our question about is there any CPU related issues or not. And now let's what do we really want to know about CPU usage when we focused on the particular application container? And we do want to know the amount of time, how long the container waited for a CPU time in the scheduling queue. So it was ready to execute, to runnable in the Linux operation system term. It was runnable, but it took some time to schedule him to some CPU core. And having this metric, we will be able to answer our questions precisely. For example, we consider an application and want to understand does it experience lack of CPU time or not? So can we fix that by adding some CPU cores into our node, into our system, or scale them? And another question is, do we have any issues because of high CPU usage on our node? And let's take a look. And a metric explaining CPU delay, where containers spend some time waiting for a CPU time, exists in Linux kernel. This feature of Linux kernel called delay accounting. It's since second major version of the Linux kernel, so it's not something new. The Linux kernel measures exact time for each each process ID or even thread ID, and we can get these metrics. It's not only about CPU usage, it's also about disk and memory access. So, but in this talk, I will focus on CPU subsystem. And these metrics, if you're talking about delay accounting itself, it's a kernel feature, and we can, from user space, we can ask the kernel for some counters for the specific process ID or thread group ID, which is pretty the same. And using netlink protocol, we open the special raw socket, and communicate from user space to the kernel space and retrieve the statistics. Alternatively, we can use a bit different approach. It's called SCAD-STAT, and we can see here for any process ID 3 numbers. The second of them is time spending in run queue, which is pretty the same. So, in our open source agent, we use netlink and communicate with the kernel to retrieve delay accounting statistics. And we implemented and open sourced our Prometheus compatible agent, distributed under Apache 2.0 license, it's pretty permissive license, so check this out. And now let's take a look at the metric. So here is a metric for some container called, it's a Docker container called app on some machine, no matter. And here is a rate of this delay accounting, CPU delay metrics for this container. And we can clearly see that here and here we have some CPU related issues, just because our container spent some time in the scheduler queue. So, and we clearly see that another point of times, we didn't have any issues. And we, to understand this, we didn't use any CPU usage, load average, and even container CPU usage. And it's pretty telling metric. And I prepared a few experiments. Here we have some application. Here is its latency, CPU delay, and CPU usage on related node. I just run some load test, and like here it started, and then I started process or container stress on the same node, and it consumed all the CPU time. As we can see, it has a lower CPU priority than our application, and we see like pretty low CPU delay. And as we can see, its latency wasn't affected. And like even with 100% CPU usage on the related node, we didn't have any, we don't see any impact on the application performance. And the opposite case, I configured my environment to run the container stress with higher CPU priority. In low-level terms, it means that while starting its Docker container, I defined higher CPU shares. And as we can see, latency of our application is affected. CPU delay is pretty high. So here we have 2 seconds per second additional latency to our requests. And with this metric, we can distinguish these two scenarios. And the same CPU usage metric, like our CPU is loaded at 100%, and we can easily understand whether our application is experiencing a lack of CPU time or not. And that's my talk mostly about. So we need to look at the right metrics. And how, if we understand that there is some CPU related issues, how we investigated them further. So the first one, what can cause high CPU delay? It can because our container is compete for CPU time with other applications. In this case, we should look at the metrics such as CPU consumers on node, and just adjust our configuration in case of using Kubernetes. It's like CPU requests and limits. Then container can consume all available CPU time on the particular node. And this time we should schedule the node vertically or scale the application, add more replicas, and so on. And also, if the container has a CPU limit, it can hit the CPU limit and will be throttled by the operation system. In this case, we will see the increased CPU delay as well. So we can check the metrics about throttling and understand what's happening. And ending my talk, few thoughts, and I offer I suggest to start pushing off CPU-related issues by looking at CPU delay metrics, which is pretty telling, and you can abstract of your troubleshooting from taking account particular nodes. So we are focusing on our application, and if we see the high CPU delay, we can go deeper and understand why it happened. But the starting point should be a metric, something like that. So that's it. Thank you. And if you have any question, I guess we have a few minutes for questions.
Thank you very much, Nikolay. So I'll check if there are questions in the online chat, but first let's see if there are any questions from the folks in the room. Okay, let's see if we have any online questions. No, I don't think so. Last chance? Yeah.
Hi. So as you're looking at these metrics, things like node delay in your application or the CPU for the pod, have you seen that maybe things behave differently in terms of having greater delays as the CPU utilization gets to you're maxing out on the particular host?
The most interesting part here that it can be considered as an absolute metric, so with pretty clear physical meaning. This is time we waited to be scheduled on the CPU core. And that's why it's pretty useful metric, because it doesn't depend on CPU usage itself. So you can clearly see low values of this metrics. It means we don't have any issues with that, or higher. Like CPU usage on the particular node is the second step. That's the idea.
And would the scheduler itself also suffer from scheduling delays?
No. I believe that the kernel threads has some priority over user space processes.
Cool. Thank you.
Great. Any other questions? Okay, so another round of applause for Nikolay. Thank you so much for the talk.
Thank you for me.
Thank you.